So, my name's Matt Kemp. I am a game director at Hadean, and I have a problem. And many people in this room have exactly the same problem, and many people, if they don't have that problem now, are going to have that problem very shortly. Now, the problem is I'm an MMO guy. I've been making MMOs for 20 years, and I love making engaging worlds. And the worlds that I want to make are just super immersive. I want to have thousands of people running around that world. I want to be able to high-five these people. I want to be able to give them things. I want them to give me things. I want to have conversations. I want to be able to see what their facial expressions are. And I want to interact with the AI in there as well. I want to be able to have good, positive interactions with these guys as well. On top of that, I want to be able to impact the world. I want to be able to create things in that world as well. And I want to do all this in an off-the-shelf game engine. But I can't. If I get more than 100 people in a world, in a game engine, I'm lucky. And the more stuff I want to do with those people means that I have more and more problems. And the reason this exists is quite simple. It all boils down to the fact that if my simulation requires more compute than a machine can give, I cannot do any more. I suffer with problems of, it's too far, I can't read it. Of problems of decreased accuracy, of problems of increased lag, of server crashes. And the way we solve these problems right now is we solve them through decreasing the amount of people in a world, decreasing the things we can do with those people in the world, and increasing the amount of isolated instances of people in this world. And this doesn't create the worlds that I want to make. Now, I say I've got a problem. I also have a solution. Now, the way we solve this problem at Hadean is we use distributed computing, where we take a world built on whatever game engine it happens to be built on. We then divide it into squares. Each square we call a cell and apply an individual piece of compute to it, so a core. Now, what this allows us to do is when we dynamically split this based upon how much compute is needed in a particular area, we can then move the compute to a simulation to the area where it's needed. So if you look at the image up here, if you look at the city, that's where everything's happening. You've got lots of people running around, you've got lots of people doing whatever they do in cities, and a lot of compute's needed to make that work. If you're on top of the mountain, you've got some snow, the odd tree, a yeti potentially. Not a lot of stuff's happening up there, so you don't have as much compute, you don't have bigger cells. And this allows us to solve the problem of getting more people into a simulation, getting more interactions in a simulation, getting higher fidelity in the simulation as well, and be able to do more stuff and create these immersive worlds. So how does it look? How does a architecture work? How does this work in the background? Well, we have the simulation. We have multiple machines in the simulation running the simulation, and then you have all your services that plug into it as well, because the simulation itself isn't the entire thing when you make something. You've got to have your billing services, you've got to have your friends lists, you've got to have your auction house systems, and then you also need somewhere to tell all the data where to go, because you've got a simulation, you've got lots and lots of different machines all over the place. You need to know where to send that data, so we have a machine in there which helps direct that off there. But there's a problem with this. If you have a piece of information on one machine, you need to send it across multiple machines. That information can take quite a while to get back to the end user. It increases lag, it increases problems. And there's a solution for this as well. This is by processing things on the edge. And so we put out edge servers that are connected really close to the end user. We then, as we know what the end user needs to see within the simulation, we can take the information from that simulation and process it on the edge server. That way, the information can be quickly relayed back to the end user, and then we can relay the information back to the simulation to make sure that stays correct. And that way, we can make sure that the experience the end user is getting in this immersive world is positive, it's good, and it is of the low latency they expect. We did this a few years ago, where we had 14,000 people connected to one simulation from 88 countries. And the experience you got, whether in the US, whether in the UK, whether in wherever else, Australia, was similar. It was good. They had good experiences. They could interact with each other. It felt good, and they really enjoyed it. So this worked really well. Now, the obvious use cases here is making games, making big games. But the reason why I think we're all going to start suffering from this soon is because there's a metaverse use case around this as well. So To give you sort of a quick history lesson, you probably all know this anyway, well I hope so. The internet started in 1969. 3 universities came together, wanted to share some information, and more people saw this and thought, this is pretty good. We're going to start connecting to this network as well. And then across the pond, other people started connecting to it. And eventually, the whole world turned into the internet that we know and love today. And we believe the metaverse is at this stage right now. We're at the very early stages of the metaverse. We've got people building stuff, but they're not connecting to each other. They're not big enough. They can't create these immersive worlds right now. And the way we see this developing, and the way we see all this sort of plugging together, is that people are going to take their existing internet content and start wanting to connect to a metaverse world, start wanting to connect to these 3D worlds. They don't want to put all the effort into creating their own 3D world yet, but they want to connect to it, say, I am part of the metaverse. But over time, as they start seeing the value of this, they'll start thinking, well, actually, I want my own metaverse world. I want my own metaverse world. I want to build it. I want to own it. I want it to run on my hardware. I want to plug all the things in it that work for me in this metaverse world, my own ad tech, my own monitoring systems. And I want to build it, own it, and be my world. And I want to decide who I connect to. And they'll start connecting or creating metaverse networks where all these people will start talking together. And then over time, as more and more of these networks are created, they will start plugging in and talking to each other as well. And you'll have many networks talking to each other, which will bring us back to what the metaverse will be. So how does this look? And this is a concept of what we're thinking about right now. You have your central world, which is built on whatever technology it happens to be. And you have your internet plugging into it, so through APIs, through SDKs, you can start building stuff on top of this world. And then you have your third-party services that you're obviously going to want to build in as well. On the left-hand side, you've got your decentralized technologies, so things such as your IPFSs, your blockchains, however they're going to be used, because I think that's still up for debate, how they're all going to end up being used, so your IDs, your wallets, all that side of stuff, we'll look at that. The exciting thing, I think, for this group is how do we get these people to talk to each other? How do the metaverse networks connect? And that's your open standards, and that's your other systems that are created in order to make these things communicate with each other. And all built on top of a world which you can scale and is big enough and is immersive enough to create those experiences that people want in the metaverse. Thank you very much.